Let's go to page 244 and number 393. So let's go ahead and draw the picture. Okay, so this is A, this is B, this is C, this is D. Okay, this is R. This small r. Okay, this is E, F, okay. Okay, so this is the small c, this is the small b, and this is the small a. Okay, so part 1, go and let ED equal to DG equal to DF equal to Y. Okay, because these are the, okay, so these two are congruent because they are tangent to the common point, and these two are congruent because these are tangents to this circle. So all three are congruent. So let's go and call this Y. And we're going to do this. We're going to just label everything. Go and call this W. Call this X. So easier to do the calculation. So you can. These are common tangents, and call this Z. Okay. Okay. So you have AB. So AB is equal to X plus Z, and BC will equal to W plus 2Y plus Z. So W plus 2Y plus Z. And AC is equal to AC equal to X plus Z. Then what we're going to do is we're going to do the AB plus BC minus AC. Okay. So we're going to add these two and we're going to subtract them. And so notice that the X AB is X plus W. Yeah, so be careful. Yeah, so it's kind of complicated, so you have to be careful. Okay, so we're going to add these two and subtract that. So notice the X will cancel out. So X and the Z will cancel out. So you're going to end up with 2W plus 2Y. Okay. Now if you look at 2WY, okay, see WY, so that's BD. So 2W plus 2Y will equal to 2 times BD. Okay. And so we're going to substitute this back. So AB is equal to C, BC is A, AC is B, and this will equal to 2BD. I'm going to divide both sides by 2, so BD equal to C plus A minus B over 2. Okay, for the next part, okay, we're going to draw this over, and we're going to call this X over here. Okay, this is the S, and this is the point R. Okay. So the radius of the big circle is S. The radius of the small circle is R. Okay, and this is the point X over here. So what we're going to do is we're going to do the part 2 over here. Okay, so from R to S is equal to the radius, big radius plus a small radius. Okay, and from S to X, from here to here is a big radius minus the small radius. So again, this is the R and this is the S. Okay, so the X, so this over here is the big radius minus small radius. Okay, so once we do that, we can use a Pythagorean theorem over here. Okay, so we have the Rx square, so that's the bottom, plus the Sx square equal to the Sr square, right? So A square plus B square equal to C square. So the Rx, so Rx we don't know, that's what we're looking for. So Rx square plus Sx is over here. Sr is equal to S plus R square. Okay, so Rx square equal to, I'm going to move this over. So I'm going to expand this. So I get x squared plus 2SR plus R squared minus, and I move this one over, right? So that's why it's minus. So it'd be x squared minus 2SR plus R squared. So Rx squared equal to, okay, so when you subtract, so this will cancel out, and this minus minus will give you plus, so it become 4SR, and R squared minus R squared will cancel out. Okay. So now you take the square root, so Rx equal to 2 square root of SR. But now if you look at your Rx, so Rx is this over here. So that's your Rx. So if you notice, it's straight down here. Okay. So that is equal to EF. Okay, because it's just straight down. But if you look at EF, EF equal to 2y, or EF equal to 2dE. Okay, so 2 square root of SR equal to, so EF equal to 2dE. Then you divide both sides by 2, so dE equal to square root of SR. Okay, let's go to the next one. And let's do number 394. Okay, so 394, the picture is giving. Okay, so let's go and draw the picture. Okay, so you got A, B, C. Okay, D is the median. Okay, so AE, okay, all these are median, so it's kind of nice. Okay. So this is F, E, okay, so you got AE, BF, CD. Okay, so AE and BF, okay, so AE is median. So that means this congruent. Okay, and BF are medians. Okay, so this is not correct. Okay. And it says CD and F. So CD and FH are parallel. Okay, so let's see. Okay, CD it is. Okay, so you got to be careful. Okay, so all these are median. Okay, and FH is parallel to and equal to AE. So you go and draw the parallel. Okay, so we got the picture now. Okay. Okay, so first you want to prove that AEHF is a parallelogram. So you want to prove that that is a parallelogram. Okay. Okay, so first we got FH is congruent to AE. So this is giving. Okay, so let's go ahead and mark that. And then you have FH is parallel to AE. Again, that's giving. Okay, and so what we need to do is prove this stuff parallel. Okay, so we have angle AEH is congruent to angle HFE, and these are alternate interior angles. Okay, so AEH and HFE. Actually, it's AEF. Okay. HF. Okay, HFE. Okay, so these two are parallel, and you cut. So it's AEF and HFE. There you go. So it's this. Okay, so it's this angle right over here, and there you go. Let's do this. Okay. And then you have the EF is congruent to EF. So this is reflexive. Okay. So you have this angle and you have this over here. So the two triangles are congruent. So you have triangle AEF is congruent to triangle HFE. and the reason would be SAS. Okay. Okay, now once we get two triangles congruent, then we have angle AFE is congruent to angle FEH, and this would be CPCTC. Okay, so we got angle, okay, angle AFE, so this angle right over here, to FEH, this one over here. Okay. And once we have these two angles are congruent, okay, then these two angles are alternate angles of these two over here. So we can see that AF is parallel to HE. And reason for that is because that if alternate angles are congruent, then lines are parallel. Okay. Okay, so we're kind of doing a regular geometry proof. Okay. Okay, and then after that, then AFHE is a parallelogram. Okay, because we have this over here, and we have this over here. Okay, so we have two pairs of. So this is the definition of parallelogram. Okay, and so that's it. Okay. Okay, now let's do the part 2. Okay, so we're going to keep this picture over here. Okay, so part 2, we have DE is parallel to AF. So we have okay, so we're going to draw this over here. Okay. Since this is a median, all these are median. So DE is a median. Okay, let's do this. So DE is median. So this is given. And then DE would be parallel to AF. So that's a definition of median. Okay. Then up to that, that DE, EH are collinear. Okay, and again, that's a definition of the collinear line. So DE and EH, okay, because this is parallel to that and this is parallel to that, so they have to be collinear, right? Because they have the same point, and since this is parallel to that, this is parallel to that, and they have the same point, so it must be collinear. Okay. And then you have ED equal to AC over 2. So ED equal to AC over 2. Again, that's the definition of median. The definition of median is that the median is half the length of the base. Okay. And also this is equal to AF and equal to EH. Okay, so ED is equal to AF equal to and they are equal, right? So this is equal to that, and this is equal to that, so they are all equal to each other. Okay, and I'm going to multiply this by 2, so you got AC equal to 2 times EH. So this is the multiplication. And then next one is HD equal to EH plus ED. Okay, so HD equal to EH plus ED. Okay, so again, that's the addition property. Okay, and then after that, and since they are equal to each other, so HD equal to 2 times EH. Okay, and this is a substitution. Then after that, HD will equal to AC. And this is transitive. Okay, so because of that, see this over here? Okay, so what you can do is substitution. You can just substitution. So substitute this into here. Okay. And then after that, you have AF is paired to HD. And this is transitive. This is from this two over here. So this came from here. And this over here. Okay. Since they're all straight line and they're paired to each other, so they have to pair to each other. Okay. Okay, so again, it gets complicated. Then after that, then you have angle CAD is congruent to angle HDB, and this would be corresponding angles. Okay, so you have the CAD and HDB. So you have these two angles right over here. Okay. Okay, so they are corresponding angles. Okay, almost done. Okay, then after that, you have AD is congruent to DB. Okay, again, this is a definition of median. Okay, so you got AD is congruent to DB, right? Because this is the median, this is the midpoint, so they are congruent. Okay. And after that, we get triangle. Okay, so let's go ahead and put more colors over here. Okay, and then we have this over here. So we're going to have a SAS, basically. Okay. Okay, so we have triangle ACD is congruent to triangle DHB. Okay, so again, so ACD and DHB. Okay, so again, it's going to be SAS. Now, once we get it to be congruent, then we can have VH is congruent to DC. So we're going to have the VH is congruent to. Okay, so we have the BH is congruent to CD. So this is good congruent to that. So there you go. So BH congruent to DC. So we can use use this color over here. And this would be CP CTC. And therefore BH will equal to DC. And this is the definition of congruence. Okay, and that's it. So you have this equal to that. So basically what you have is you have a trapezoid, okay, like this. So So if you draw it, you get a trapezoid. Okay. So now let's go to part 3. Okay, so part 3, you want to prove that FG, you want to prove that this is a median of the FG is median of a triangle BFH. Okay, so this is the median of this over here. Okay. So prove that this is the median of this triangle. So we need to prove that. Okay, let me see. Okay, we can prove. Well, if this is a median, then you need to figure this is the midpoint. Okay, so FG is parallel to AB. So FG is parallel to AB. Okay, so that is giving. Okay. And so F is midpoint of AC. So F is a midpoint of AC. So that is a definition of median. Okay, so F is a midpoint of AC, so that's a definition of the median. So FG is median. Okay, so what happens is if you have midpoint and you draw so this is a definition. Again, this is another definition of median. So what happens is when you have like a trapezoid, okay, or even a triangle, when you so you can look at a trapezoid. So when you start from the midpoint and you draw a parallel line to the base, right? So if this is the midpoint and you draw the parallel line, then this would be a median. Okay, and that's it. Okay, let's go to 4. Okay, so we need to prove the FG is 3/4 of AB. So this equal to 3/4 of AB. Okay, so FG equal to FE plus EG. Right, so FG is FE plus EG. And FG equal to AD. So FE, remember these are parallel, right? So FE is AD. And EG is 1/2 dB. Again, look at this one. So this is median, right? So this is half of that. Okay, so this is equal to that, this is equal to half of that. And FG, so AD is 1/2 AB. And DB is 1/2, okay, AD is 1/2 AB. And DB is 1/2 AB. Okay. So notice this 1/2 is over here. This is over here. Okay, so just do the simple math. Okay, so 1/2 AB plus 1/4 AB. So FG equal to 3/4 AB. Okay, and so that's it. So again, these are just our basic math.